So dear students, good evening to each and everyone. We are studying signals and system in comprehensive manner. Already we completed total 16 lectures and this is lecture number 17. In last class we have seen how to calculate energy of a continuous time signal and we solved certain questions also. Okay. So first of all tell me, am I audible properly? Audio and video both are clear to you people? Tell me in the comment box. Okay, fine. So let us continue further. Lecture number 17, calculation of energy, and this is part 2. So let us start with this question. Sinusoidal function a sin t plus theta, and we want to calculate the energy of this signal. Okay. What is the formula? Energy of any signal is given by integration minus infinite to plus infinite. As this is a real value signal, so square of this signal, that is a square into sin square t plus theta dt, x square of t into dt. Sin square theta equal to what? 1 minus cos 2 theta divided by 2. So here this is a square by 2, 1 by 2 is common, is minus infinite 2 plus infinite, 1 minus cos 2 theta, it will be t plus 2 theta divided by 2 into dt. Already I took 1 by 2 common, so need not require to write 1 by 2. Now let us split this integration. A square by 2 integration minus infinite to plus infinite is dt minus a square by 2 integration minus infinite to plus infinite cos 2t plus 2 theta. Okay. Now tell me what is the answer of second integration, guys. This is nothing but what? Integration minus infinite to plus infinite cos 2t plus 2 theta dt. So this integration indicates the total area of cos signal. Total area means area from minus infinite to plus infinite. So what is the area? If I am talking about the cos function, this is the cos function. So minus infinite to plus infinite, what will be the total area? So total area is 0. Why? Because positive half cycle area is equal to negative half cycle area but opposite in sign. Okay. So area of one cycle is 0. Positive half cycle area is equal to negative half cycle area but opposite in sign. So that's why total area for one cycle is 0. And there are infinite number of cycles. So that's why total area is 0, guys. Integration of cos function from minus infinite to plus infinite indicates the area under cos function, which is 0. In short, the answer of second integral is 0. Here answer is 0 for the second integral. And if I am talking about first one, so here integration of second part, so it is a square by 2, integration is t, limit is from minus infinite to plus infinite. If you put upper limit and lower limit, then of course you will get answer infinite. So energy is infinite. We can say energy of sinusoidal function is infinite. Suppose if it is a question, instead of sin, cos is there, guys. If a cos t plus theta, then here 1 plus cos 2 theta divided by 2, guys. Okay. So again answer will be 0 for cos function also, guys, because there is a only 90-degree phase shift between sin and cos, guys. Okay. If suppose additional phase shift is not there, then also answer is 0, because all the sinusoidal signals are periodic and all the periodic signals are what? All the periodic signals are power signal. So here this is the actually power signal, and power signal has infinite energy. Later also we will see, guys. So by formula we got energy infinite. So energy, ideally speaking energy of the sinusoidal function is infinite, guys, because this sinusoidal function start from minus infinite and ends at plus infinite everlasting signal, infinite duration signal. Is this clear? Is this clear, guys? Fine. So energy is infinite. Now let us take next question. Okay. Now this is the complex sinusoidal, guys. Complex sinusoidal, and we want to calculate energy of this complex sinusoidal function. So complex sinusoidal. Why complex sinusoidal? Because e power j theta Euler's form a cos omega t plus j a sin omega t. So energy of complex value signal, because real part is a function of t, imaginary part also function of t. So energy of real value signal is given by minus infinite to plus infinite mod. First of all, you have to find the magnitude of x of t, magnitude of this real value signal, and then you have to do the square and then integration. So what will be the magnitude? If I am talking about magnitude, so magnitude of a into e to the power j omega t. So magnitude is what? Under root real part square plus imaginary part square. So a square cos square omega t plus a square sin square omega t. If you take a square common, then sin square theta plus cos square theta equal to 1. So finally you will get magnitude a, guys. Simply you can say magnitude of e power j omega t is equal to 1. E power j theta is equal to 1. So here in this case also energy will be infinite. Again, this is also a power signal. Minus infinite plus infinite a square dt, energy is infinite, because again this is also power signal, guys. That's why this is the reason. Let us take one more question. If you have any doubt, then write in comment box. If you have any kind of doubt, then you can write it in the comment box. Okay. Now ramp function, already yesterday we have seen, I think, what is the energy of this ramp function. See, if it is the increasing function or function maintaining the constant amplitude for infinite duration, a function which is maintaining constant amplitude for infinite duration, then energy will be infinite. Energy of the signal will be finite only when if it is a decreasing function right side or decreasing function left side or decreasing function both this side, or we can say if it is a finite duration signal, finite amplitude, finite duration signal, then and then energy will be finite, otherwise infinite. So let us consider this signal and let us calculate energy of this signal. So we know that R of t is nothing but what? T into Q of t. Energy of this signal, integration minus infinite to plus infinite, square of this function. We know that u of t equal to 1 for t greater than 0. So if you replace u square of t equal to 1, then the limit will be 0 to infinite. It is t square into dt. Again you can see, guys, the energy of this ramp function also finite because it is an increasing function. T cube divided by 3, 0 to finite, here also energy signal. See, energy is infinite, that doesn't mean the power will be finite, guys. It can be neither energy nor power signal also, correct? Here power, if we calculate power of this signal, then power also will get infinite, guys. Later we will see. So as this is increasing function, right side increasing function, infinite duration increasing function. So energy is what? Infinite. Got it? This is nothing but ramp function R of t. I hope all the students are getting. Tell me in the comment box, is this clear to you people? Clear? Okay. Now next, now let us find the energy of a finite duration signal. Certain finite duration signal like rectangle pulse, triangle pulse, half sinusoidal waveform. Okay. Suppose this is given a rectangle pulse. 0 is B, amplitude is A, general x of t signal, rectangle pulse. So what is the width of this pulse, guys? Width is nothing but width of the given signal t is equal to B, guys. And what is the amplitude, guys? Height, we can say the amplitude is A. Amplitude is A, max amplitude is. So let us calculate energy of this signal. Energy Ex of t is given by minus infinite to plus infinite real value signal x square of t dt. So x of t is nothing but A between 0 and B. So x square of t, it is A square, and the change in limit is 0 to B, guys. So it will be A square t 0 to B. So answer is A square into B, guys. So this is the energy of rectangle function having width B. You can see this is the energy of rectangle function having width B and amplitude A, guys. A square into B. A square into B. Now tell me, can time shifting operation alter energy of the given signal? Here you can see, guys, what is B? B is nothing but width, and what is A? Amplitude. So from this, the important conclusion is energy of the given signal. Energy of given signal is directly proportional to square of amplitude of the amplitude, and energy is directly proportional to width. Correct? As you can see here, energy is directly proportional to square of the amplitude and is directly proportional to width of the given signal. So if there is a change in width, then and then there is a change in the signal, change in energy of the signal. And if there is a change in amplitude, then and then there is a change in the energy of the given signal. So tell me, can time shifting operation, right shift or left shift, alter the energy of the given signal? No, guys, because in the time shifting operation there is a no change in width of the given signal, there is no change in amplitude of the given signal. So that's why we can say time shifting operation doesn't alter energy of the given signal. Suppose I am asking to find energy of the signal y of t, here x of t minus b, guys. T minus b means right shift by b unit. The signal will shift right shift by b unit, guys. You can see right shifted by now right shift by b unit means add b here. So this is 0 from 0 to b. Now after shifting it will be from 0, this is b to 2b, there is no change in amplitude. This is x of t minus b. Now again calculate energy of this signal. So energy of this y of t. Now integration is from b to 2b, again square is a square dt. So you can see here energy remains same, guys. Energy remains same whether signal is right shifted or left shifted. So energy remains same. Even time reversal operation also doesn't alter the energy of the given signal, because in time reversal operation there is no change in the width, just folding with respect to y axis. So time reversal operation, just wait for a minute, guys. So in the time shifting operation there is no change in the signal width and no change in the signal amplitude. That's why time shifting operation and time reversal operation also doesn't alter energy of the given signal. Can we say like this? So important conclusion is that you have to write in this short note, if energy of the signal x of t is E, then energy of the signal t minus t naught. Now t naught can be positive, it can be negative, it can be integer, it can be non-integer, energy remains same. There is no change in energy of the given signal. Okay. Even time reversal operation also, guys, because in these two operations there is no change in the signal width, and I told you energy is directly proportional to width of the given signal, it is directly proportional to square of the amplitude. So energy remains same. So this is very much important conclusion that you people have to write in your short notes. Correct? Now tell me, not audible? Am I audible? Sound is clear or not? Am I audible properly? I think sound is clear from my side. Okay. Now tell me, if you perform time scaling operation, if you perform the time scaling operation like time compression or time expansion, then definitely there will be change in the energy, because in the time scaling operation signal width can change, it can increase or it can decrease depending on the value of time scaling factor alpha. So same question, guys, same question. Now I am asking, let us consider, find the energy of y of t equal to x of 2t, x of 2t. So here x of 2t means time expansion or compression. Of course here scaling factor is greater than 1, that's why time compression. So time compression already we have studied, it is, this is 0. Now due to time compression b by 2, guys. So there is a change in the signal width by times for by time scaling operation. Now width is equal to b by 2, and you can see energy is directly proportional to width of the given signal. In the same factor energy also decreases, guys. Let us calculate energy of this y of t signal. So it is nothing but, again, now integration 0 to b by 2 square, signal square, so a square dt. So it will be a square into b, a square into b divided by 2. So we can write here energy of this y of t, energy of this y of t is nothing but energy of x of t divided by 2, and here scaling factor is 1 by 2, guys. What is the scaling factor? Scaling factor is 2 greater than 1, time compression. Clear? So energy is what? Ex by 2, guys, Ex by 2. Now let us take this example. Suppose x of t divided by 3, x of t divided by 3, expansion or compression. So here scaling factor is 1 by 3, which is less than 1. So expansion, signal width increased by the factor of 3, guys. Now the width will be 3b. This is 0. Now b become 3b. There is no change in amplitude, amplitude remains same. So energy of this signal, now this time energy of y of t, integration will be 0 to 3b x square of t dt. So here energy will be a square into 3b. Can you write like this? A square into b into 1 by 3, 1 by 3, guys. So here we can write energy of y of t is nothing but, this is what energy of x of t divided by 1 by 3. See, scaling factor alpha equal to here scaling factor alpha equal to 1 by 3. Okay. So in general what we can say, guys? In general Sound is not clear? Wait, let me. Pretty much clear from my side. So let us continue further. So in general, what we can say, guys, what is your final conclusion? The final conclusion is, if energy of x of t is, if energy of the x of t signal Ex, then tell me in the comment box, energy of x of alpha t, where alpha is a scaling factor, what will be the energy, guys? Alpha can be greater than 1, it can be less than 1, it can be positive, it can be negative also, guys. Alpha can be greater than 1, it can be less than 1, it can be positive, it can be negative also, it can be minus 1 also, guys. So in general, what we can say? In general, what we can say? So in general, we can say, see here, Ex by, you can see here, Ex upon Ex by alpha, and here this is also what, guys? Ex by alpha. Check once. Alpha equal to 1 by 3, alpha equal to 2. So in general, we can write Ex upon mod alpha. Why I am writing mod, guys? Why I am writing mod? Suppose if alpha equal to minus 3, then time reversal operation doesn't change energy of the given signal, correct? So that's why we have to write mod alpha, because alpha can be negative, but time reversal operation doesn't alter energy of the given signal. So that's why mod alpha we have to write. Suppose alpha equal to minus 3, and if you are writing minus Ex by 3, so energy cannot be negative. So that's why I am writing mod alpha. Alpha can be positive, it can be negative, but time reversal operation doesn't alter energy of the given signal. That's why I am writing Ex upon mod alpha. Yes, very good, guys, you got the point, correct? So in this we can add further. In this we can add, guys, what we can add? Here we can add Ex of alpha t, then the energy of this signal is given by Ex upon mod alpha, correct? Ex upon mod alpha. Time scaling can change. Now what about amplitude scaling? If you multiplied x of t with k, then tell me what will be the energy, guys? What will be the energy? See, energy is directly proportional to square of the amplitude. Square of the amplitude. So tell me, in this case, what will be the energy? If you do the square of this signal, so it become k square, guys, correct? So it is nothing but k square into Ex. K square Ex. Suppose I am writing x of alpha t minus t naught. Time shifting and time scaling both present, then simply have to focus on time scaling operation only. So again here also Ex upon mod alpha, and suppose I am writing k x of alpha t minus t naught. So time scaling, time shifting, time reversal, amplitude scaling, then here see k square due to amplitude scaling, and due to time scaling it is nothing but Ex upon mod alpha. Any doubt in this? So this is very much important conclusion, guys, that you people have to remember. Very much important conclusion. Write this in the short notes, guys. Tell me in comment box, is this clear to each and every student? This is very much important conclusion. Okay, so what is the final conclusion? Final conclusion is, the energy of any rectangular function, this is the rectangular function, any type of rectangular function having a width capital T, location of this rectangular function can be anywhere, like completely left side, completely right side, or partially right side, partially left side, guys. But simply you have to focus on the width of this rectangular function, like T1 to T2, and amplitude can be positive or it can be negative. This amplitude can be positive, can be negative, partially positive, partially negative. So if this is the signal rectangle pulse having a width T and amplitude A, then its energy is given by A square into T. So simply remember this thing. Got it? Clear to each and every student? Amplitude can be negative also, guys, but energy will be always positive, because here we are writing we got the square of the amplitude. Fine. Let us continue further. Similarly, let us take half sinusoidal waveform, half wave of sinusoidal function, half wave, only half wave. Only half wave, correct? This is the half sinusoidal waveform. Width is, again, let us consider B. Peak amplitude is A. Here peak amplitude is A, width is B, guys. Width of the given signal is B, peak amplitude is A. This signal is x of t. So see, this is the finite duration and finite amplitude. This is the sinusoidal waveform. This is the part of sine function, correct? Sine function, part of the sine function, and as this is the finite duration and finite amplitude signal. So as duration is finite and amplitude also finite, so energy will be finite. First of all, we need to find its a mathematical expression. This is the sinusoidal function, of course, but it is between 0 and B. So first of all, we need to find its a mathematical expression between 0 and B, guys. So first I am writing the complete sinusoidal waveform. If it is the complete sinusoidal waveform, complete sinusoidal, that means like this, okay, complete sinusoidal waveform. Let us write y of t, infinite duration, complete sinusoidal, okay. Fundamental time period is C, fundamental time period. Compare with this. So what is the time period for half wave? For the time period half wave, this is the half wave, consider this is the half wave, amplitude A. So for the half wave it is B, okay. So this is B, then of course for the negative half cycle duration also B, so it become 2B. Now if he wants to write the mathematical expression for this complete sinusoidal means it is a sinusoidal function from minus infinite to plus infinite. So we can write like this, y of t is nothing but, what is the peak amplitude? Peak amplitude is A, okay, and negative side it is minus A, okay. Then phase shift is 0, then it is peak amplitude is A into sine omega t, where omega is equal to what? And this is for minus infinite to plus infinite. T is from minus infinite to plus infinite. Omega is 2 pi by capital T, guys. 2 pi by capital T. What is the fundamental time period? So fundamental time period is 2B, guys. See, the fundamental time period is 2B. So fundamental time period you can see here 2B, okay, from here to here. This is the fundamental time period, correct? So fundamental time period is 2B. So omega will be pi by B. So y of t here, y of t is equal to A sine pi by t, but this is the sinusoidal function, everlasting, infinite duration sinusoidal function, infinite duration, starting from minus infinite, ending at plus infinite. This expression is for t from minus infinite to plus 1, but we want only this half wave guys between 0 and b. So here if we wants to express x of t in sinusoidal function, so this is the, can we say this is the part of this sinusoidal function, this x of t is the part of y of t, x of t is nothing but it is y of t only, but between 0 and b, between 0 and b, so you can say it is a sine pi t by b, but this expression is only for t between 0 and b, and outside this range we can say 0, yes or no. So this is very much important, getting the mathematical expression, Any doubt? Any doubt? Clear? Okay, very good. Now we can calculate the energy because we got the mathematical expression. So energy of the given signal, see limit will be 0 to b, integration limit will be 0 to b guys, and we have to do the square of this signal. So a square into sine square pi t upon b dt. Okay, so energy, again a square by 2 common, sine square theta equal to 1 minus cos 2 theta divided by 2. So 0 to b, 1 minus cos 2 pi t divided by b dt. Okay, so it will be a square by 2 integration 0 to b dt minus a square by 2 integration 0 to b cos 2 pi t by b dt. Now tell me what is the answer for the second integral. What is the answer of second integral? Just calculate this second integral and tell me what is the answer. What will be the answer of second integral? Tell me in the comment box, and I am expecting answer from each and every single student. Zero. Very good guys. So of course, if you have calculated this, then you should get 0 answer for this second integral. And what is the answer for the first integral? It will be b. So we can say here simply the energy of this half sinusoidal waveform is a square into b divided by 2. Again you can see here energy is directly proportional to square of the amplitude, and it is directly proportional to signal width guys. Again you can see directly proportional to width of the given signal and directly proportional to peak amplitude of the given signal. Correct? Okay. Again time shifting operation, time reversal operation doesn't alter energy of the given signal. So energy remains same for whatever the location of this sinusoidal function. In short, we can say if any half sinusoidal waveform, half sinusoidal wave, sinusoidal pulse also you can say, having a width, suppose this is T1. T1 can be positive, it can be negative, it can be 0. Similarly T2, width is T, and if peak amplitude is A, if peak amplitude is A, okay, peak amplitude is A, then energy of this half sinusoidal waveform is given by peak value for A square into width is T divided by 2. So this is very much important conclusion. Any doubt in this? Any doubt? Is this clear to each and every people? Clear to each and every student? Okay, very good. Similarly, let us consider any single triangular pulse. This is the sinusoidal pulse. Previously we saw the rectangle pulse, and now next is triangle pulse, triangular pulse, like this. Let us consider this triangular pulse, and what will be the energy of this triangular pulse. For simplicity, I am considering a right angle triangle, and the final answer will be applicable for any type of triangle, whether it is right angle triangle or any other type of triangle. Correct? Remember this thing. For simplicity only, I took here right angle triangle. This is 0. Let us consider here maximum amplitude of this triangle is A. Now again, we need to find the mathematical expression of this line, guys. See, of this ramp function. We need to find the mathematical expression for this line in general expression, that is expression for minus infinity to plus infinity, like we have done in the previous, okay, we have done in the previous example. So let us consider a y of t signal, y of t signal. It is a straight line passing through origin, straight line passing through origin, guys. What is the slope here? So you can see this is the ramp function. Ramp function having a slope. What is the slope? Slope is dy by dx. dy by dx. Slope is a by b. So here same slope we need to consider. Ramp function with the slope is a by b. Now we can say y of t signal is nothing but y equal to mx, a straight line passing through origin, guys. Y equal to mx, straight line passing through origin. What is the slope? M equal to a by b. A by b. And what is the value of x? On x axis we are considering t. But this is the expression of line from minus infinity to plus infinity. This is a general expression, minus infinity to plus infinity. But we want this ramp function between 0 and b only. So x of t we can write, x of t is nothing but, we can say x of t is a part of y of t. Can we say x of t is a part of y of t? So x of t we can write like this, x of t is nothing but a upon b into t. Now it is between 0 and b, guys. 0 less than equal to t less than b. I am not writing equal to here because there is a sudden change in amplitude, but no issue. Okay. So now calculate energy. Energy of this signal is given by integration again 0 to b. Now square of this signal, so a square upon b square into c square dt. So here a square by b square is a constant value. Integration of t square is t cube by 3. Limit is 0 to b. It will be a square by b square into t cube by 3. So the final answer is a square to b divided by 3. So the energy of rectangle pulse is a square into b divided by 3, guys. Now see, for simplicity only I took the right angle triangle, and this formula, this concept is applicable for any type of triangle, whether it is right angle triangle or any other type of triangle. Correct? So remember this thing. Derivation is not required, Nikhil. Derivation is not required. I will provide you summary also. See, this summary also I will provide, and simply you have to remember this summary. Okay, and then we will solve the different question also. You can see different questions also. Fine. Okay, now exactly what I am saying is this is applicable for any kind of triangle. Any kind of triangle. Suppose, see, any kind of triangle. So this is a triangle pulse like this. Triangle pulse. Simply you have to focus on the total width of the triangle, guys. Simply focus on total width. You can see here B is the width, guys. B is width of this triangle. A is a peak amplitude. Width is T. And if it is x of t signal, then the energy of this triangle pulse is a square into width divided by 3. Clear to each and everyone? Clear to each and everyone? A square into t divided by 3, guys. Suppose I am asking calculate the energy, find, suppose I am asking find energy of, find energy of x of t is equal to 3 triangle function e by 4. Calculate energy of this function. Calculate the energy of this function. Tell me your correct answer in the comment box. So this is the standard triangular function. Standard triangle function with peak amplitude is 3, and here this 4 indicates it is from -4 to +4. This is from -4 to +4. Amplitude is 3. Peak amplitude is. Now what is the width? What is the width of this given triangle? Width is A, 8. Energy of this triangle is given by a square t divided by 3. A square into t divided by 3. This is the peak amplitude. So energy is peak amplitude, that is a square, t square into, what is the width? Width is 8 divided by 3. Answer is 24. If you want to write unit, joule, or you can write unit also. So we got energy of x of t is 24 joule. Very good guys, correct. So in this manner also they can ask the question. Okay, now they can ask question like this also, like x of t is equal to 2 r of t plus 3 minus 4 r of t t minus r of t, okay, r of t, r of, let me write here, t plus 6, t plus 6, okay, and here t plus 2 plus 2 r of t minus 2, x of t is given, okay, this is the x of t, and they are asking to find energy of this signal. Try this question, tell me your answer in comment box. Try this question and tell me your answer in comment box. The mathematical expression is given, draw it graphically, then it would be very much easy for you people. So you got answer 512 divided by 3, final answer, numerical answer type question. So it's a numerical answer type question, so you have to give answer in the numerical value type answer. 170.67, okay, let me check guys. So first of all, draw it graphically. So one ramp function is starting from t equal to minus 6, one more is at t equal to minus 2, and one more is at t equal to 2 guys. So ramp function at from t equal to minus 6 with the slope 2 guys. Here slope is 2. Now see, slope is 2 guys. What is amplitude at this point? So dx dy slope is 2. Dy we need to calculate, dy, this is dy and this is dx. So dx is 4. So of course dy equal to 8 guys, correct? Dy equal to 8. So here dy is equal to 8. So this amplitude is 8. Peak amplitude is 8. Now here next set from t equal to minus 2, one more ramp function with slope minus 2, previous slope is plus 2, present is minus 4, so next is what? Minus 2. It is minus 2 till next signal. Again you can see dy is 8, dx is 4, so slope is here, the value of slope is minus 2, and from t equal to 2, one more ramp function with the slope plus 2, so next is 0 guys, correct? So here also we are getting triangular function, okay. So what is the total width of this triangular function? Tell me the width of this triangular function. So width is 8. Width is 8. What is amplitude? Amplitude is also 8 guys. Energy of x of t is given by peak value square, that is 8 square into width 8 divided by 3. So calculate this, tell me the right answer. $170.67 guys. The answer should be numerical answer type question 170.67. Okay, if they are asking rounded off up to 2 decimal places, then answer should be 67. Rounded off up to 3 decimal places, the answer should be 170.667. rounded off up to 4 decimal places, the answer should be 170.6667. Okay, so remember this thing. Okay, now let us summarize all the concept. So see, first is what? Exponential decreasing. First is exponential decreasing, right side, e power minus a into t. Of course, a should be positive, then exponential decreasing. So what is energy? What is the energy of this x of t? Energy of x of t, exponential decreasing, so energy is 1 by 2a. Even exponential decreasing, left side, so for this also energy of x of t is again 1 upon 2a. Time reverse operation doesn't alter energy of the given signal. Now rectangle pulse having width t, amplitude a, then energy for this signal given by a square into width t. Now here sinusoidal pulse, this is sine function, it can be cos also, no issue. Sinusoidal function having width t, amplitude a, then here energy is given by a square into width t divided by 2. Here triangle function guys, with width t, amplitude a, then energy of this triangle pulse is given by a square into t divided by 3. Is this clear? Clear to each and every? So this thing you have to write in your short notes guys, this much only. Okay, so write this summary. SN means short notes. SN indicates short notes, and you have to prepare short notes also guys. Prepare short notes regularly, because at the time of revision the short note will be very much helpful for you people. Okay, any doubt in this? So now depending on the property of this property, depending on the property, based on this property, let us solve some questions. Okay, revise this property quickly, and we will solve question based on these properties. Okay, and this is valid only for the continuous time. For the discrete time we will see all the properties. Okay, this is for the continuous time. So let us solve some questions based on this property. Okay, so let us solve this all 10 questions. See, the question is, if energy of the signal x of t is 8 joule, then find the energy of the given signals. So total 10 questions, and I am giving only 5 minutes. Only 5 minutes to solve all the questions, and the questions based on the property, I am giving only 5 minutes to you people, and your time only 5 minutes. I am giving only 5 minutes to solve all 10 questions. I think 5 minutes are more than sufficient to solve all the questions, and your time starts now. Use the property and solve all 10 questions. Done? Okay, very good. Still, you people have 3 minutes to solve all 10 questions. Still. Okay. Shall we start, guys? Sinchan, Sinchan Reddy, tell me. You also completed all these questions. So first is what, guys? Time shifting. So I told you guys, see, energy is, again I am saying, energy is directly proportional to square of the amplitude, and it is directly proportional to width of the amplitude. Sorry, width of the given signal. So if there is a change in width, if there is a change in amplitude, then and then there is a change in energy of the given signal. Now time shifting operation doesn't alter width or amplitude of the given signal. That's why time shifting operation and even time reversal operation also doesn't change energy of the given signal. So energy remains same for the first question. So energy for the first question is 8 joule, same as x of t. Same, guys, 8 joule, correct? Remains same. Now again, this is what left shift, again energy remains same, left shifting operation, 8 joule. Here time reversal operation, again time reversal operation doesn't alter energy of the given signal, again 8 joule. Now here, see, here you can see x of 3t, so scaling factor is 3, time scaling factor is 3, okay, compression or expansion. So here scaling factor 3, which is greater than 1, so compression, so signal width is decreased by factor of 3. In the same way, the energy also decreased by the same factor. So E is nothing but the scaling factor, E. The scaling factor alpha is equal to 3, that's why E is equal to 8 by mod 3, so 8 by 3 joule. Now here in fifth question, what is the scaling factor? Scaling factor is minus, so it is minus 5s, minus 5, then energy is E upon mod alpha, E upon mod alpha, so here 8 divided by mod alpha, so mod minus 5, so energy will be 8 by 5 joule for this question number 5. Now here you can see the scaling factor, alpha is minus 3, so energy E, energy is equal to 8 divided by mod minus 3. Okay, so here energy is 8 by 3. What about here, guys? So scaling factor, again you can see the scaling factor for this, here scaling factor is 0.2, so energy will be 8 divided by mod 0.2, so it is 40 joule, guys, 40 joule. Now here amplitude scaling, guys, amplitude scaling, so 3 into x of t, amplitude scaling factor 3, so directly proportional to square of the amplitude, so 3 into 8, okay, so it is 72, 9 into 8, 72 joule, guys. Clear? Now here this is very much important, guys, this is very much important, just you have to focus on the scaling factor. So in this case the scaling factor is minus 4 by 5, yes or no? Minus 4 by 5 t, the scaling factor is minus 4 by 5, that's why energy is 8 upon mod minus 4 divided by 5, so it will be 10 joule, correct? And in the last case, K is equal to, see, amplitude scaling factor 2 and the time scaling factor is 1 by 2, so energy is, due to amplitude scaling factor, it is 2 square, and here 8 divided by scaling factor 1 by 2, guys, so it will be, this is 4 into 2, 8 into 8, 64 joule. Is this clear to each and everyone? Is this clear, guys? So here In this way, by using the property, we can solve all the questions. Okay. So guys, let me finish this lecture here, and all of you, thank you so much watching me live on Get Wallah English channel, and please don't forget to provide your valuable feedback in the comment box, and next part we will continue into subsequent module. Thank you guys, thank you so much.